let's try this one. Limit as x approaches 0 from the right of e to the x plus 3x to the 1 over x. First, checking on the form that we're looking at here. So e to the 0 would be 1, non-zero number to the 0 is 1, plus 3 times 0. So the base here approaches 1. The exponent, if you have 1 over, denominators approaching 0 through positive numbers, anytime you have non-zero number over 0, and you can determine the overall sign, which we can here. 1 is definitely positive. We're instructed here that we're approaching 0 through positive numbers, so the overall sign here is always positive. Then this exponent here is approaching infinity. So we're looking at 1 to the infinity, which is an indeterminate form. We'd really like to use L'Hopital's rule, which means we'd really like to see this written as a ratio. Right now it's written as an exponent. So the procedure for dealing with that is the same as what I showed in the previous example. It's to first, let's plant a flag at the limit that we're actually seeking here, which is this one. So I'm just copying down the limit that I gave you initially. And then take natural log of both sides of that equation. So the natural log of L is equal to the natural log of this limit. As I said before, since the natural log function is continuous over all positive numbers, and this is a positive number, whatever we plug in for x that's slightly positive, then it's a continuous function, so we can move the limit inside. Sorry, move the logarithm inside of the limit. Oops, and that's not infinity. That's 0. We approach 0 through positives of natural log of e to the x plus 3x to the 1 over x. The whole point of bringing in the logarithm is to bring this exponent down. So this is equal to the limit as x approaches 0 through positive numbers of 1 over x times natural log of e to the x plus 3x. Okay, but again, what we really want to see is a ratio. So let's go one step further with that. This is the natural log of e to the x, need to write bigger, I know, plus 3x over x. If you multiply this straight across, 1 times that natural log over x times 1. Forget this limit. Make sure I'm recording. Okay. I'm not just talking to myself. So now we should check on the form. Let's see. Well, so denominator is certainly approaching 0. Oops, this is supposed to say form. Okay. Denominator is approaching 0. Numerator. What's going on with the numerator? This is e to the 0, which is 1, plus 0. So numerator here is approaching natural log of 1, which is 0. So we now have the form 0 over 0, which means we can apply L'Hopital's rule. Good news. Can I write on the bottom of the board here? I think I can. So this is equal to, I'm going to write bigger this time, limit as x approaches 0 from the right of derivative of the bottom is just 1. We'll do the easy part first. Derivative of the top. We got to use the chain rule. So differentiate the natural log function first. Derivative of the natural log function is just 1 over, leave the inside alone. So e to the x plus 3x times the derivative of the inside. Derivative of e to the x is e to the x plus the derivative of 3x would be 3. And I'm going to need to bring this up. So this is equal still to natural log of L. So I'm going to come up here. I'm going to erase what we have here, I suppose, and copy that last step. So at this point, we know that this limit is equal to this down here. Let me go ahead and clean it up. So this is 1 times this e to the x plus 3 over e to the x plus 3x. And then all of that over 1, which we don't need to write. So now this limit has the form infinity over infinity. Oops, no it doesn't. Sorry guys, it's just like being in class. I make these little mistakes, these little boo-boos. I was thinking of x approaching infinity. It's not, it's approaching 0. So now if we substitute 0, we have e to the 0, which is 1, plus 3, over e to the 0, which is 1, plus 3 times 0, which is 0. So we have 4 over 1. So 4. So this limit is equal to 4. That means, okay, if natural log of the limit, keep in mind, is equal to 4, then in order to solve for just the limit L, which is the limit that we actually seek in this problem, we should take e to both sides. Because exponential expression base e and logarithm, that's the logarithm base e, natural log, those cancel each other out. They're inverse operations. And so we end up with just L equals e to the 4th. And so in this case, 1 to the infinity is equal to e to the 4th. And that's our final answer.